Hi, you guys. We're going to go on to lesson 2, and this is still chapter 1. So we did some vocabulary before, and now we're going to continue in the notebook. So make sure you have these notes, and we're going to be doing pages 7 through 12. Okay? 7 through 12. As soon as I can get this focused. There we go. Okay, so we're going to start talking about measuring and constructing segments. This is chapter 1, lesson 2. We're going to talk about how to measure and construct stuff. Now, normally this exploration would be done together. We're not going to do that since I want to keep these short, but we are going to talk about a straight edge. So right down here, it says a straight edge is a tool that you can use to draw a straight line. Now, if you think about when this geometry started, the ancient Greeks, that's all they had was just a straight line. So we didn't have a ruler per se, but a ruler is the best thing to have. You should have one on hand at all times. You could use your ID card or a small ruler. There's an example. Okay, so let's talk about our vocabulary and stuff. Again, page 8 is also exploration. We're not going to do that right now. But we are going to talk about like what is a postulate? What is an axiom? Again, these are in that vocabulary Quizlet that I gave you. Okay, but an axiom, I should start with postulate. A postulate is a rule that is accepted without proof. We all agree that that postulate is true, a rule that is accepted, accepted without proof. Now, an axiom is also a rule that is accepted without proof. So they're sort of interchangeable. If something's basic to a premise, it's often called axiomatic. Okay, when we talk about a coordinate, it is a real number and again, you are writing this down in yours that corresponds to a point on a line. So a coordinate is a real number that corresponds to a point on a line. Distance is the absolute value of the difference. Hopefully you understand that implies subtraction of two coordinates on a line. Now, construction, think of it means like building things. Construction is a geometric drawing that uses a limited set of tools. Again, think back to the ancient Greeks. Usually, the only thing you can use for a construction is a compass and a straight edge. So it doesn't necessarily have to be a ruler. We'll be calling it a straight edge. Now, congruent segments are line segments that have the same length. Okay. And last for this section, we're going to define between, and I'm going to do this in a sentence, when 3 points are collinear. One point is between the other two. So whenever we talk about vocabulary, this is really important for you to memorize, basically. And we're going to have a lot of vocabulary in this chapter. Go back to the Quizlets and study those if you need to. We have two postulates in this section. One is the ruler postulate. The points on a line can be matched 1-to-1 with the real numbers. Okay, so every point has a real number. That real number that corresponds is called the coordinate of the point. So if I say x1, x sub 1, and x sub 2, that's because I'm going in the horizontal direction, which we always call x. If I was going vertically, I would call it y. That's the way we do it. The distance between A and B, then, we write it as AB. That distance is right here. AB is the absolute value of the difference of A and B, which means AB is equal to the absolute value of x sub 2 minus x sub 1. These are points. These are numbers. So A and B are points. This is the difference between the numbers. So AB, AB. Okay, so we're going to go on. If you have two congruent segments that are the same length, we're going to call those congruent, okay? Which means you can say the length of AB is equal to the length of segment CD, or you can say segment AB is congruent to segment CD. This symbol, super important. Oh my goodness, I wasn't on the camera. This symbol here, it's an equal sign with a squiggly on top. It's called a tilde. Okay, so this is super duper important. You always need to know that this means congruent. It means it's the same size and the same shape. Okay, so you can say that the length of AB is the same as the length of CD. It's equal to. Right here, lengths are equal. But segments are congruent. And that means their shape is exactly the same too. So this is size and this is shape. We're going to distinguish that like throughout the year. Add those to your notes. Super important. Okay, second postulate, meaning something that we are going to accept as true without a proof. If B is between A and C, then segment AB plus segment BC is equal to the total of AC. So here's AB, and here's BC. And so what this says is you can add them together. If AB plus BC equals AC, then B is between these two. So that is a definition, right? So you can add this plus this to equal the whole thing. This part plus this part to equal the whole thing. That's called the segment addition postulate. And it kind of looks obvious, doesn't it? That's the most beautiful thing. So let's turn our page. So some of these problems that we're going to be doing, the extra practice on page 11, in exercises 1-3, plot the points in the coordinate plane. Then determine whether AB and CD are congruent. So I have all four quadrants here. The first thing I'm going to do is draw my axes in. Okay, so there's my Y. I'm going to do it for all three. There's my Y. There's my Y. And I should just be able to go all the way across with this. Okay, so here's my X. Here's my X. And here's my X. All right, here we go. A is -5, 5, so -5, 5. I put an A next to it. B is negative 2, 5. I'll put a B next to it. C is 2, negative 1, 2, 3, 4. And D is negative 1, negative 4. So I can count 1, 2. This is 3 units. And this is 1, 2, 3 units. So yes, they are congruent. I'll go ahead and write that out. Number 2, 1, 2, 3, 4, 0 is A. 4, 3 is B. Negative 4, negative 4 is C. Negative 4, positive 1 is D. So this looks like 1, 2, 3, 4, 5 units. And this looks like 3 units. So no, they are not congruent. All right, let's move on. Number 3, so negative 1, 5 is up here. And then 5, 5 is up here. I forgot to label A, B. Okay, and then C is 1, 3. And D is 1, negative 3. So let's count that. That's 1, 2, 3, 4, 5. There's 6 there. And here there's 1, 2, 3, 4, 5, 6. So yes, they are congruent. Great. Let me know if you have any questions when we get together for class. In exercises 4 through 6, find VW. Okay, so VW is from here to here. WU is 8. So the segment addition postulate says that VW plus WU equals VU. If I'm looking for VW and I know that WU is 8 and VU is 31, then what number added to 8 will give me 31? I subtract 8 from both sides and I get VW equals 23. I always make sure I box or circle my answers. Okay. For each one of these, I've got VW plus UV equals UW. VW is what I'm looking for. Plus 6 equals 18. What number plus 6 equals 18? So I want to undo adding by 6. I get 12. And again, the same postulate, only now VW is all of it. So this is WU from here to here plus UV, and that's going to equal VW. So WU is 45, UV is 30, and so VW is 75. I make sure I box circle my answer. Okay. I'm going to have you do number 7 on your own as a warm-up during class. So get that done before we start class for the next section when we're going to go over these. And I look forward to seeing you soon. And now that you've done that problem, this is just a little teaser. This is what your work should look like or something like this. Okay, see you soon.